How China pumps billions of gallons of river water across an entire continent is one of the most audacious engineering stories ever told. China built a network of canals, tunnels, and aqueducts stretching over 2,700 miles to move water from its flooded south to its dying north. The project has already transferred 76.7 billion cubic meters of water, enough to fill Lake Erie nearly twice over, and it is still only two-thirds complete. But to understand why China was forced to attempt something this vast, you first need to understand just how close its northern cities came to running completely dry. The country that is running out of water. Imagine turning on your tap one morning and nothing comes out. Not a temporary outage, not a burst pipe somewhere down the street. Nothing, because the aquifer your city has been drawing from for 100 years has finally been pumped past the point of no return. And the water that used to sit 20 feet below your street now sits 1,000 feet down, and the wells that could reach it cost more than your city can afford to drill. This is not a hypothetical. This is the future that China's northern cities were accelerating toward. China has roughly 20% of the world's population. It holds just 7% of its fresh water, and the distribution of that water is catastrophically uneven. 80% of it sits in the south, nourishing the Yangtze River Basin and the provinces that surround it, while the north, home to the capital, the breadbasket, and hundreds of millions of people, sits on a landscape that receives less rainfall than parts of the American Southwest. Beijing's per capita water availability is around 120 cubic meters per year. To put that in context, the global standard for absolute water scarcity is 500 cubic meters per person per year. Beijing gets less than a quarter of that. It is one of the most water-stressed capital cities on the surface of the earth. But the numbers on paper are not even the most frightening part. The most frightening part is what was happening underground. For decades, as Beijing grew, as its population swelled, as its factories multiplied, as its farms spread across the North China Plain, the city did what cities do when surface water runs short. It drilled deeper and deeper wells, pulling from the aquifer beneath the city faster than rain could ever replenish it. The groundwater table fell 9 meters between the year 2000 and 2011. 9 meters, almost 30 feet of water depth, gone in 11 years. At its worst, Beijing was sinking an average of 5 centimeters, roughly 2 inches every single year, as the soil beneath it compacted into the space where water used to be. Buildings cracked. Subway tunnels shifted. Infrastructure designed to last a century was being undermined by the ground quietly collapsing beneath it. And the experts were saying something that China's government could not ignore. Drain that aquifer deep enough, and you do not get it back. Deep groundwater aquifers take thousands of years to form. They do not refill in a human lifetime. Once it is gone, and the safety net that Beijing had been relying on for a century disappears permanently with it. There was a word being used in the hydrology reports that nobody in government wanted to see attached to a city of 20 million people. The word was irreversible, as in irreversible subsidence, irreversible aquifer depletion, irreversible damage to the infrastructure of a capital city that every road, every subway line, every water pipe, and every building foundation was depending on to hold its position underground. The scale of the problem demanded a solution that matched it, and the only solution large enough to match the scale of northern China's water crisis was something that had never been attempted anywhere on Earth. Mao's dream, the idea that took 50 years to build. In 1952, Mao Zedong stood on the banks of the Yellow River and said something that most of the engineers and officials in his company thought was fantasy. The South has plenty of water, the North has little. Borrowing some is fine. One sentence, an offhand remark made on an inspection tour. And somehow that sentence became the seed of the most expensive, most expansive water infrastructure project in the history of human civilization. But it did not become that quickly. The idea sat in planning documents, engineering studies, and government reports for 50 years. Engineers studied the terrain. Economists debated the cost. Environmental scientists raised alarm after alarm about what redirecting billions of cubic meters of river water would do to the ecosystems that depended on it, and the numbers kept growing. The projected cost of building all 3 planned routes, $62 billion. For context, that was twice the cost of the Three Gorges Dam itself, already the most expensive infrastructure project ever completed at the time. The human cost was equally staggering. 330,000 people living along the planned routes and around the expanded reservoir would need to be relocated. Many of them did not want to go. Some signed relocation agreements under pressure from officials who had been given quotas to meet. Villages that had existed for generations disappeared under rising water. And through all of it, the cost overruns, the environmental objections, the international criticism, the forced relocations, one reality kept reasserting itself in every government meeting and every engineering review. Northern China was running out of water, and it was running out faster than the debates about how to fix it were being resolved. So China made a calculation. The cost of building it was enormous. The cost of not building it was the slow collapse of northern China's water supply, and with it, the economic, agricultural, and political stability of the country's most densely populated region. There was only one answer. Construction on the eastern and central routes began in 2003. The full project was projected to take until 2050 to complete. China committed to a generational infrastructure undertaking that would reshape the country's geography permanently and whose total cost, as of 2024, had already surpassed $70 billion, with the western route not yet begun. But what China was actually building, the sheer physical scale and engineering complexity of it, is something that no single budget figure can capture. 3 routes, 1 mission. The South-North Water Transfer Project is not one canal. You need to understand that clearly before anything else. It is 3 separate mega-projects, each one a massive engineering undertaking in its own right, running simultaneously across the eastern, central, and western spine of China. Together, when complete, they are designed to move 44.8 billion cubic meters of fresh water every year from the wet south to the dry north. That is nearly 12 trillion gallons of water every year, moved by human infrastructure across a continent. The eastern route is the oldest of the 3. It follows the path of the ancient Grand Canal, a waterway that Chinese engineers first began building in the 5th century before the Common Era, making it one of the oldest artificial waterways on Earth. The modern eastern route stretches over 1,150 miles from the Yangtze River in Jiangsu Province north to Tianjin. Using 23 pumping stations with a combined capacity of 454 megawatts to push water uphill against gravity in stages like a staircase of water climbing north through the flatlands of eastern China. The central route is the most dramatic. 1,264 kilometers of open canal, engineered with such exacting precision that water flows from the Danjiangkou Reservoir all the way to Beijing entirely by gravity, no pumps. No mechanical assistance, just a perfectly calculated downhill gradient maintained across more than 700 miles of varied terrain. To make this possible, engineers raised the height of the Danjiangkou Dam by 14.6 meters, adding 11.6 billion cubic meters of storage capacity and requiring the resettlement of 330,000 people from the Klipkame. Land now sitting beneath the expanded reservoir, over the canal's full length, engineers built 1,300 bridges over it, bored 140 tunnels beneath it, and in 2 places, did something that still stands as one of the most audacious moments in modern civil engineering. They ran the canal underneath the Yellow River. 2 tunnels, each one 9.3 meters in diameter, roughly 30 feet across. Bored 70 meters, that is 230 feet beneath the bed of the Yellow River, under water pressure of 4.5 times atmospheric pressure. Tunnel boring machines that could not stop once they started, because any pause in the saturated sandy riverbed under that kind of pressure risked catastrophic inflow and collapse. Engineers worked around the clock to keep the machines moving, boring through geology that had never been mapped at that depth, under a river that carries more sediment than any other on Earth and has a documented habit of shifting its course without warning. Then there is the western route, still unbuilt, still in planning, and the most audacious of all three. The western route is planned to cross the Qinghai Tibet Plateau at altitudes ranging from 10,000 to 16,000 feet higher than the summit of Mont Blanc, boring through the Bayankala Mountains in a seismically desiccated, active earthquake zone to bring water from tributaries of the Yangtze to China's most parched interior provinces. The engineering challenges alone are staggering. The environmental and geopolitical stakes are even higher, but the western route is still a plan. The eastern and central routes are real, and what they have already delivered is something that was barely imaginable when Mao made his offhand remark 70 years ago. The engineering no one talks about. Put yourself inside the problem China's engineers faced when they sat down to design the central route. You need to build a canal that carries billions of cubic meters of water per year across the densely populated heartland of the world's most populous country. That canal has to cross over 1,200 existing rivers, roads, and railways, none of which can be closed because they serve millions of people every day. It has to pass through earthquake zones. It has to maintain a perfectly consistent downhill gradient for over 700 miles across terrain that is anything but uniformly flat. It has to do all of this without contaminating the water, which means every construction site, every connection point, every junction where the canal meets an existing waterway has to be engineered to keep pollutants out of a supply that hundreds of millions of people will drink. And it has to bore under the Yellow River. The Yellow River crossing stands alone as the single most technically demanding element of the entire project. 2 tunnel boring machines were lowered into purpose-built shafts on the southern bank and pushed north through the riverbed at a depth of up to 230 feet below the surface. The machines operated under 4.5 bar of water pressure, the equivalent of pressing 4.5 kilograms of force against every square centimeter of the tunnel wall, continuously, for the entire length of the bore. If the lining failed, if a seal cracked, if the machine stalled too long in the saturated sand of the floodplain, the consequences would have been catastrophic and irreversible. But the Yellow River tunnels were not the only crisis, not by a long way. Think about what else the central route had to do before a single liter of water reached Beijing. The canal crosses 1,200 existing rivers, roads, and railways. At each one, engineers had to choose build a bridge carrying the canal over the obstacle, or bore a siphon carrying it underneath. Either way, the crossing had to be engineered with enough structural integrity to survive decades of continuous water pressure, seismic activity, and seasonal ground movement without cracking. The sheer number of those decisions, 1,200 of them, each one a distinct engineering problem requiring its own solution, is a number that does not get discussed in the headline stories about this project. But it is the texture of what it actually meant to build it. The eastern route faced a completely different kind of problem. The Grand Canal corridor passes through some of the most industrially polluted waterways in China. When engineers surveyed the route in detail, they found that dozens of the lakes and tributaries the canal would pass through were so contaminated by decades of industrial discharge that the water could not safely be sent north to any city in any quantity. The entire premise of the eastern route, the oldest, the most natural path, the one following a 2,500-year-old waterway, was threatened not by geology or engineering, but by pollution. China's response was not to reroute the canal, it was to clean up the country the canal passed through. Over 1,000 polluting enterprises along the eastern route corridor were shut down, fined, or forced to upgrade their systems before a single drop of transferred water was sent north. Entire industrial sectors were restructured. Wastewater treatment capacity along the corridor was expanded on a scale that would have been a landmark environmental project in its own right in any other country. A nation that had spent 40 years industrializing at maximum speed paused to clean up the waterways it had spent 40 years contaminating because a project of national survival required it. And it required something else too, something the engineering plans never explicitly budgeted for, but that turned out to be the hardest part of all. Moving 330,000 people who did not want to leave. What it changed and what it cost. 330,000 people, That is the number of human beings relocated to make this project possible. Most lived near the Danjiangkou Reservoir in Hubei and Henan provinces. Communities built around river fishing, farming, and land their families had worked for generations. When the reservoir expanded, their villages went underwater. The temples, the schools, the graves, the paths worn into the hillsides by people who had walked them every day of their lives. All of it submerged. Some families were moved twice, once when the original Danjiangkou Dam was built in the 1960s, and again when it was raised for this project 40 years later. Imagine being told at 60 years old that the place your family had rebuilt after the first displacement, the place you had spent your adult life turning back into a home, was going underwater again. The relocations were not all voluntary. Human rights organizations and journalists, documented residents pressured into signing agreements, compensation paid below market rates, and communities moved to areas without the farmland or fishing access their livelihoods depended on. The official project literature does not dwell on these details, but they are part of the complete story of what it cost to move a river. And yet the transformation the project has delivered is measurable, peer-reviewed, and in some places genuinely remarkable. Beijing's groundwater table, which had reached 25.6 meters below the surface by 2014, began recovering the moment the central route went live. By 2020, it had risen by 3.6 meters. By 2024, Beijing's groundwater had returned to depths last seen in 2005. The subsidence that had been sinking the city at 5 centimeters a year began to slow, then stop, then in some districts reverse. A subsidence zone covering 1,377 square kilometers in 2015 had shrunk to just 78 square kilometers by 2022. The Yongding River, which had run completely dry for 26 consecutive years, flowed again for the first time in 2021. Today, 2 out of every 3 cups of water consumed in Beijing's urban areas traveled over 1,000 kilometers along the central route from the Danjiangkou Reservoir in Hubei province, a 15-day journey. 185 million people across 45 cities now receive water from the project. The economic output it has supported in northern China exceeds 16 trillion yuan, over $2 trillion US. But then there is the question no official report answers directly. What happens to the south when the north's thirst keeps growing? In 2011, a drought hit the Han River source region so severely that water levels in the Danjiangkou Reservoir fell to the point where both the communities sending water north and the cities receiving it were left short simultaneously. The project built to solve a water shortage had temporarily contributed to one. Climate projections suggest the South's water surplus, on which the entire system depends, will become less reliable as temperatures rise and rainfall patterns shift. The project moves water brilliantly, but it does not create it. And the western route, the piece still unbuilt, sits above rivers whose downstream flows sustain populations across Southeast Asia and South Asia. The Mekong, the Brahmaputra, rivers that do not belong only to China and whose diversion would be felt across borders in ways that no engineering solution can fully contain. Controlling water is controlling the future. Come back to that canal, 2,700 miles of it. Moving silently through the heartland of China, past farms and factories and ancient waterways and mountain ranges carrying water from the Yangtze River basin north to a capital city that was quietly, measurably, irreversibly drinking itself dry. It takes 15 days for water to travel from the Danjiangkou Reservoir to a tap in Beijing. 15 days across 1,000 kilometers of engineered gradient, through twin tunnels bored 230 feet beneath the Yellow River, over aqueducts spanning highways and railways, through treatment plants and distribution networks, to the glass you fill at your kitchen sink, without thinking about where it came from or what it took to get there. That water passed through communities that were resettled to make way for it. It traveled through tunnels bored by machines that could not stop once they started. It flowed along a canal whose construction required cleaning up 1,000 industrial polluters that had been discharging into China's waterways for 40 years. Every cup of it carries a history that most of the 185 million people drinking it have never been told. What China built here is not just infrastructure. It is a statement about what a nation will do when the alternative is unacceptable. $70 billion, 330,000 people relocated. 2 decades of construction, 76.7 billion cubic meters already delivered. And the project is still only 2/3 complete. The western route, crossing the Tibetan Plateau at 16,000 feet, boring through earthquake country, drawing from rivers that feed 1 billion people across 6 countries, has not yet broken a single foot of ground. But here is what stays with you when you look at the full picture. Humanity has always followed water. Rivers determined where cities were built. Rainfall determined which lands could be farmed. Droughts ended civilizations that could not adapt when their water ran out. For all of recorded history, the geography of water has been one of the most immovable constraints on where and how human beings can live. China looked at that constraint and decided to move it, not metaphorically, physically. 2,700 miles of canal, tunnel, and aqueduct. Billions of gallons flowing uphill, underground, across a continent, because a government decided that geography was a problem to be engineered around rather than a limit to be accepted. The water is already flowing. The cities are already drinking. The aquifer beneath Beijing is already recovering. And the project that Mao sketched in a single sentence on the banks of the Yellow River in 1952, the one that every engineer who heard it thought was fantasy, is reshaping the map of the most populous country on Earth, 1 billion gallons at a time.